So I just thought I'd run through some of the solutions of the logs and indices test because I could see there was some problems with some of the questions. So this first one here is worth 10 marks. It gives you a hint to allow y to equal 3 to the x. So what we're going to do is we're going to go along and we're going to break up as much as we can each of these bits. So I'm going to write 3 to the power of 2x, 3 to the power of 2. Minus 28, 3 to the x. This bit's already done for us, plus 3 equals 0. Now, I'm just going to break this up a little bit further. Because I want to use 3 to the x, I'm going to use 3 to the x and put the 2 outside. That's just your rule of indices. 3 squared is 9. Minus 28 to the times 3 to the x plus 3. So everywhere I have 3 to the x, I'm going to change it for y. So that's 9y squared minus 28y plus 3. Now, once I have written it in that form, I can use my minus b formula. A is 9, b is minus 28, and c is 3. So minus b plus 28 plus or minus the root of b squared minus 4ac all over 2a, which is 9. Now, when we pop this into our calculator, 28 plus the root of minus 28 squared minus 4 bracket 9 bracket 3 all over 2 times 9. So I'm getting one answer. Now my answer is y. So y is 3. The reason it's y is because this equation is in terms of y. I do the same thing. Then I go back and I change just the plus to a minus to get my second answer. So y is 1/9. Now I'm not actually done. Solve means I find x. So what I'm going to do now is I'm going to allow, so remember y is equal to 3 to the x. So in other words, 3 is equal to 3 to the x, or 1/9 is equal to 3 to the x. Now, there's two ways you could do this. You could start introducing logs, or you could just do index equations. I'm going to just do it using index equations. So what I do is I just make sure they have the same base. Technically, that's a power of 1. And if the bases are the same, you can ignore the base, and then we know that x is 1. So that's one answer. Now over here, I'm also going to do index equations. So to make the bases the same, first of all, I'm going to change 9 into 3 squared, but I'm still not in the, I suppose, it's not really written the way I want it to be. So I'm going to bring up that 3 to the power of minus 2. Now, again, if the bases match, you can ignore them and you just compare the indices. So the answer is x is 1 and x is minus 2. And in the test, that was worth 10 marks. In the next question, we have the natural log of square root of x plus 1, x minus 1, where x is bigger than 1, where x is an element of OR. Use the rules of logarithms to find the derivative of f of x. Give your answer in this form. Okay, so my first thought here is that anytime I have a square root, it could be written as power of a half. So that's probably a good starting point. So x plus 1, x minus 1, power of a half. Now we know when we're dealing with logs, we can bring the powers to the front. So, and this is before now, we're not actually differentiating just yet. So that becomes a half. A natural log of x plus 1, x minus 1. Now, at this stage, I want to differentiate it, but this thing here is too complex. So what I'm going to do is I'm going to let u equals to x plus 1, x minus 1. So this becomes a half natural log of u. Now, when I differentiate that bit, so the number in front is not going to change. Now, if you look at your log tables when you go to differentiate, so this is page 25, when you're doing the natural log of something, a basic term like x or u, it just becomes 1 over. So this just becomes 1 over u. Now, that part is differentiated, but of course, u itself is a fraction. So in other words, it's really 1 over x plus 1, x minus 1. Now, that looks a bit messy, of course, so you'd need to tidy that up. Now, you could either do this on the side, or maybe you know that 1 over a fraction just means that the fraction basically gets inverted, or you can do it on the side, whichever suits you. So if I tidy it up just one little bit more, multiply in 2x plus 2. So that is as simple as I can make that side. Now, the problem is, right now, I have dy du, but over here, I need to get du dx. And then the hope is that finally, if I multiply the two of them together, I end up with what I need, which is dy dx. So dy du is the bit that I've done here. Du dx is the bit that I'm about to do. And when I've done both, I should be able to bring it together to get my final answer. So, okay, so over here, so really I just need to do the quotient rule. Now I know I've used u before, but we're thinking of this almost as a completely separate question now. So I'm just going to differentiate this here. So u, I'm going to let u is equal to x plus 1. I'm going to let v equals to x minus 1. It is the quotient rule. So I'm going to just get my du dx, which is 1. My dv dx is also 1. Now I use my quotient formula. The quotient formula is on page 25. V times du dx. Now, in the exam, please write out the formula. I'm just speeding things up here a little bit. U times dv dx all over v squared, which is x minus 1 squared. Tidying up the top line, x minus 1, careful here, minus x minus 1. So when you multiply that minus in, it goes into this part as well, all over x minus 1 to be squared. The x's cancel, so I'm left with minus 2 over x minus 1 squared. Now remember, I need to multiply these together to get my final answer. So x minus 1 times minus 2 all over 2x plus 2 over x minus 1 squared. Now one of the x minus 1s is going to cancel with him. So I end up with minus 2 over 2x plus 2, x minus 1. Now I think I'll multiply this out so we can see what's happening. So that's 2x squared plus 2x minus 2x minus 2. They cancel. Now we're very close to the answer at this stage, but remember at the top of the page it says the answer has to be in this form. Now let me write it out so you can see it. The answer is supposed to be in the form a over a minus ax squared. Now while it's close, it's not exactly that. So I'm going to factorize out a minus 1 from the top. I'm going to factorize out a minus 2 from the bottom. And that leaves me with minus x squared plus 1. Now the 2's cancel there, but the minus cancels as well. So that ends up giving me 1 over, no, let's see now, sorry, that's minus 2. So that's 1 over 1 minus x squared. Yeah. So that's our answer. So in other words, a is actually 1. If you compare it to this, because the minus 2's cancel, and we're left with minus x squared plus 1. So when I just rearrange that to look like the other, you can see that a is in fact 1.